I want to clean the ocean with robots.
Robots? Let's talk about a real-world deployment. I'm here with Sebastian from Au-Zone to do just that.
Thank you. So yeah, first of all, it's not exactly a robot in the ocean, but it's a camera platform built on the same type of premises. So we're doing spatial perception to detect and map out plastic debris in the ocean on this camera platform that's built on NXP technology. So it's an i.MX 8M Plus with the neural accelerator inside. And with this, we're running a model that can detect the smallest debris of plastic in the ocean at about 100 meters out. So as you can imagine, it requires very high resolution imaging. So the model is actually able to process a full 4K frame at the edge in less than 6 watts.
This is fascinating to me, but let's take a step back and can you just dig into what is the problem statement?
For sure. So the ocean cleanup, their mission is to remove the plastic debris polluting the oceans. They tackle this through two groupings. One is the Rivers Project, where they stop the plastic from entering the ocean in the first place.
So prevention.
Exactly.
Okay.
Which is key, but there's many, many rivers.
Yes.
And then the ocean cleanup, that group is responsible for then collecting the debris once it's in the ocean. So they've been focusing, I think, primarily on the Great Pacific Garbage Patch, but they're looking to, I guess there's 5 major collections of debris that need to be collected. And part of the problem is where to go. These missions are very expensive. They require 2 ships. They're about 2 kilometers apart.
Wow.
The giant net. There's a great video showing how this all works. And it's amazing, the amount of plastic they pull out of the ocean. But these missions, they're expensive. They need to find where they go. They're out for about 6 weeks at a time.
Okay.
So they were looking for a way to find out the hotspots, where to send the vessels. And they started undertaking research into this with airplanes where somebody's looking down just to find where it collects. They've done hyperspectral satellite imagery, flying drones. But the one that they figured would be the most scalable would be just a simple camera. So they set out to prove that with a GoPro connected to a PC, running, a YOLO model, as most people do. And the initial results were good. So from there to scale it up, they knew they needed to bring that down into a self-contained unit. And that's where we paired up with them to build the ATIS unit.
Okay, so really looking at finding the most effective and efficient way to find where you can make the biggest difference and looking at some other methods which really can't scale because they're cost too much, require too many big equipment and coordination. So giving them something like this is a really small form factor. So I could see how this will bring like scalability and just how much can be done, the impact of it.
Exactly. So the way to map all the oceans is they want to install this on merchant vessels, cruise ships, any vessel of opportunity. And to do that, anybody needs to be able to just bolt this on, apply power, and it goes. So the unit is entirely self-contained. It has GPS and it has a modem. So when it gets to port or near port and finds a cellular connection, it can upload the metadata. It's very unreliable. And out in the ocean, there's no cell connection.
Exactly.
So for the most of its life, it has no connection. It needs to do all the processing offline and collect the metadata, where it saw debris, how much, how long it was able to track it for, and where on Earth.
And this is a continuous theme along all of these topics we're discussing related to mobile robotics, about scalability and then intelligence at the edge. So this is a really unique use case for that. And the fact that it goes under ships and data just is collected automatically. So it's a very autonomous, intelligent solution.
Exactly. And, while it's not exactly a robot, the way we've built it is like you would build a perception platform for a robot.
What's different? What makes it not a robot?
Well, I mean, it just sits on its own.
Yeah.
But being serious, it runs the same type of Zeno type technology that some of the other videos have talked about. So a ROS-like system where the perception is handled, but instead of sending direct instructions on where the robot should go, we're logging where we see debris, and then eventually that will turn into where the vessel that collects the debris.
Hence the term ocean mapping.
Ocean mapping, exactly.
Okay.
So there's not a real-time component to the control, but there's only so much memory, and the plastic's flying by. So it does need to run in real time.
Great. And as NXP and Au-Zone, we've partnered together in many areas. What are the specific technologies and components that you found valuable from NXP in this use case?
Well, the i.MX 8M+ does provide basically everything we needed. The baseband modem, that's a separate chip on an M.2 expansion, and the GPS is separate. But otherwise, there's an ISP for the image processing. We're running the camera at 4K, so it's 8 megapixel. That's a lot of data.
Yeah.
All that processing is able to run all the way through the NPU, where the model is predicting at about 2 frames per second. So it's not very fast, but for this application, that's all we need, 2 frames per second. But at 8 megapixel, that's pretty impressive. So
is this run on batteries?
It can, yeah. The whole platform runs in just under 6 watts.
Okay.
Power was actually very important, even though it's typically powered from the ship main power. Because of safety precautions and regulations, we need to keep power to a minimum to avoid risk of fire or electrocution and whatnot. So to install it, really it's just you give it power, and the parameters, height off ship. And from there, everything else can be managed remotely. There's an IMU inside the camera, so we can know the pose of the camera.
Okay.
And using that and the detections, we do a homographic projection to predict the distance of the debris. And that's really useful for predicting density and other types of statistics related to the ship only sees so far out, and the ocean is vast.
Yes.
But the ocean cleanup has done a lot of research on what density means, and if you see this much debris, there's a likelihood that it's pretty homogeneous over some distance from the ship.
A real world, I should say, deployment that's having an enormous impact to help us clean up the oceans. We all know and have heard about the enormous amount of plastic and how that impacts then the sea life or the ocean life, and then that impacts everything else, right? So this is really interesting, and to see the same technologies that we build mobile robotics out of get used in this type of situation just shows the scalability of the technology.
Exactly. I'm curious to see where else the
Yeah.
mobile robotics will go, even for non-traditional robotic applications.
Thank you for joining us on this conversation at the Edge. To learn more about this collaboration, check out our blog in the link below.